I seem to be going backwards on this copper and carbon battery project that I'm working on. You'll actually see there's 1, 2, 3, 4, 5, 6, 7 cells here at the moment, and nothing is working. When I started doing this, I was using the carbon rods out of the middle of AA batteries. They're 50 millimeters long, and if I measure across them, good contact, we've got about an ohm, less than an ohm. And if I put my meter leads together, my meter leads account for nearly half an ohm, well, 0.3 of an ohm there. So it's dropping down a little bit, 0.2 of an ohm now, but yeah, so we need to knock a little bit off. I'll get another good contact. Yeah, I would say we're probably talking half an ohm for 50 millimeters. So about 1/10 of an ohm for a centimetre, something like that. What I've done is I've replaced those carbon rods with conductive paint coated coffee stirrers. I thought it would be a good idea, but these things, if I go along about the same distance, they're significantly higher resistance. They're about 10 times the resistance. If I measure about 50 millimeters, we're on about 5K. So 5K, no, not 5K compared to half an ohm, that's 1,000 times the resistance. Now, I think that's what my problem is here. I think I've got too much resistance with all of these coffee stirrer rods. When I first set this up, I was getting about 0.12 volts off each cell. I'm getting, no, I'm the wrong way around. I'm getting 50 millivolts. So I've lost about half the voltage. $20 millivolts. I'm not quite sure what the problem is. 30 millivolts. This is going to be in the way, so we can't see it. Yeah, now that's what I was getting. Let's try and get the probes out of the way so you can see. Yeah, that's what I was getting. So nearly 0.2 of a volt. 1.8 I was getting before. Sorry, 1.2 I was getting before. So that one's showing about 1.2. Now it's dropping away. 1.3. 0.13. So yeah, when I measured them before, I was getting 0.12. So I reasoned 0.12, 0.24, 0.36, 0.48. That would have been 0.6, 0.72, and then the final one should have given me about 0.84 volts, or 840 millivolts, which should be just enough to run one of these solar rockers. I reckon they need about 0.8 of a volt. But somehow or other, when I've left them, they've lost their conductivity. Whether there's something being deposited on the copper or the carbon that's actually dropping their conductivity, I'm not quite sure. I've looked at them and I've cleaned them. Let's just do that. If we measure this one, right, we're down to 0.03. So about a quarter of what we did have. If I take that one out, there's something on the surface. I'll clean it and see if we get a different resistance, a different voltage. All right, giving it a good clean. Pop that back in there. Measure it. It's gone up a bit, but it's not up to the 120 millivolts, or 80 millivolts. Yeah, improved it, but not much. So I really am at a bit of a loss as to why I'm getting such bad readings. If we go across the whole lot, let's see, where do we start and where do we finish? We start on this one and go up to that one. Yeah, we're only getting about half a volt, 0.45 of a volt. I should be on double that, according to my theory. If we disconnect, yeah, no. Need to disconnect the solar rocker so we are just measuring battery on its own. Hang on, don't want that on there either. That's that fella. Okay, so negative there. Well, it's gone up a bit because we had the load on there. Now we've got no load. We're going up to 0.66 volt. Yeah. It's not working. That is just that fella on there. Ignore the fact he's rocking at the moment. That's because I've just knocked him. Just disconnect him. You see he's still rocking a little bit even though he's disconnected. We connect up this one instead. That's the solar flower. And we've got nothing at all. Yeah, we're just not doing it. If I disconnect that one, connect it onto this bit of magnesium, stick that in there, and I think you can see the difference. So carbon to magnesium, no problem at all. Carbon to copper, have to wait for that to stop. Right, carbon to copper. We won't be getting anything. I'll just measure that carbon to copper. Yeah, about 15 millivolts. Carbon to magnesium, over a volt. 1.2, yeah, 1.2 volts. The reason I started this experiment was simply because I didn't really think it would work, carbon to copper, because they were fairly close on the galvanic table. But I thought if I added enough of them in series, we would get the voltage. But we're not. And I am confused as to why we're not. There must be something I'm doing wrong. I haven't fixed anything. I've just put a couple of zinc strips in, one there and one there, just to measure what voltage we get there. I'm getting about half a volt now. 0.67, which is actually just enough to get this one beginning to move. He says as it stops. Just measure across that one on its own. That's about 0.5, no, nearly 0.6. And that one on its own. Oh, that one's over a volt. Between all of them, yeah, about half a volt, maybe 0.6. If I give it a little push, it will actually keep it going. But it really needs about 0.8 of a volt to run on its own. So yeah, somehow or other we're just not getting the voltage from the carbon and copper. I'll put a link to my video on the galvanic table, because there's a couple of, well, there's lots of galvanic tables and they contradict each other as to where copper should sit. But yeah, you see he's going now. I've given him a little bit of a tap. And that is on, let's do that again. Yeah, about 0.6. But that's not what we wanted to achieve. We wanted to achieve it with copper and carbon, and we're not doing it. If we look at the display on the clock, I've disconnected the solar rockers. We've nearly got a display. If I actually go back 2 cells to one that's just got the zinc on it, we've actually got enough for the display. So we're losing power from some of these cells rather than gaining it. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.